Hello everyone. Welcome to the Thinknyx YouTube video on the incredible capabilities of Google Cloud. From its advanced computing capabilities to its robust storage options, powerful big data and machine learning tools, and versatile application services, Google Cloud stands as a one-stop solution for all your technological needs. So let's embark on this journey together to explore the boundless possibilities that Google Cloud offers. Our agenda for this session includes an overview of Google Cloud, understanding regions and zones, exploring the range of services offered, understanding resource hierarchy, and a live demonstration on how to create a basic compute engine instance. Without any more delay, let's dive right in and get started. Google Cloud is Google's cloud computing platform that offers a range of services for building, managing, and scaling applications and infrastructure in the cloud. It provides businesses with the flexibility, scalability, and reliability they need to leverage the power of cloud for their operations. Google Cloud started its existence from 2008 with the launch of a product called App Engine, a developer tool that allowed customers to run their web applications on Google Cloud infrastructure. By late in 2011, App Engine was pulled out of preview mode and officially announced as a fully supported Google product. After this, Google has continued to build and provide more services and products to enhance their cloud platform. Google Cloud Platform empowers developers by offering a robust, secure, and reliable infrastructure that enables them to create, experiment, and launch applications with ease. With a diverse range of services, including computing, storage, big data, machine learning, and application development, developers have access to a comprehensive toolkit to build web, mobile, analytics, and backend solutions. One of the standout features of Google Cloud Platform is its pay per second billing option, providing cost efficiency and flexibility for users. Furthermore, Google Cloud not only delivers infrastructure as a service and platform as a service solutions, but also extends its reach into the software as a service domain through offerings like G Suite, now known as Google Workspace. It's worth noting that Google's vast ecosystem of products, such as Google Search, YouTube, and others, they all leverage the same underlying Google infrastructure. There are over 100 services that Google Cloud offers. Some of the popular Google Cloud services include Compute Engine Service, App Engine. It is a fully managed platform as a service that allows developers to build and deploy applications easily. App Engine supports multiple programming languages and provides automatic scaling and load balancing. App Engine is suitable for a wide range of use cases, including web application hosting, microservices architecture, rapid prototyping, automatic scaling, and mobile backends. Google Kubernetes Engine. GKE is a managed Kubernetes service that is commonly used for deploying, managing, and scaling containerized applications. It is ideal for the organizations that require a highly flexible and scalable infrastructure for running production-grade container workloads, enabling efficient resource utilization and streamlined container orchestration. Google Compute Engine. GCE is an infrastructure as a service that provides virtual machines for running applications. We are going to talk about this more in detail in the later part of this video, and we'll also have a look at the demo on its creation. GCE is suitable for businesses that need customizable and scalable virtual machine instances to run their applications and workloads in the cloud with control over the underlying infrastructure. Now the next is storage. Cloud Bigtable is a fully managed petabyte scale NoSQL database service that is optimized for high throughput and low latency. Cloud Bigtable is well suited for applications that require high performance and scalable storage for massive amount of data such as time series data, IoT data, or high traffic analytics workloads. Cloud storage. It is a scalable, durable, and highly available object storage service. It is ideal for the organizations that need a reliable and scalable solution for storing and serving various types of data, including files, images, videos, backups, and logs, with easy access and strong durability across applications and services. Cloud SQL. It is a fully managed relational database service that supports MySQL, PostgreSQL, and SQL Server. It is a valuable choice for businesses that require a fully managed and highly available relational database service, enabling them to run and scale their applications with ease while offloading the burden of database management tasks. Cloud Data Store. It is a fully managed NoSQL database service that offers high availability, scalability, and strong consistency. It is particularly useful for applications with rapid changing data requirements and dynamic workload patterns. Operations. Cloud monitoring. It is a comprehensive monitoring and observability service that collects metrics, logs, and other performance data from your cloud resources. It helps businesses proactively identify and resolve issues, optimize resource utilization, and ensure optimal performance and reliability of their cloud infrastructure. Cloud logging. It is a centralized logging service that allows you to store, search, analyze, and monitor logs from your applications and infrastructure. It integrates with other Google Cloud services and provides an advanced filtering and alerting capabilities. It allows organizations to collect, analyze, and monitor logs from various sources in their cloud environment, enabling them to troubleshoot issues, detect anomalies, and gain insights into the operational performance of their applications and infrastructure. Error reporting. It is a fully managed service that helps you identify and understand your application's errors. Error reporting automatically collects error data from your applications and sends it to cloud logging, where you can view and analyze it. By automatically collecting and consolidating error data from multiple sources, it enables businesses to quickly diagnose and resolve issues, improving the overall reliability and performance of their software. Google Cloud resources are hosted in multiple locations worldwide. These locations are composed of zones and regions. At the time of recording, GCP spans across 112 zones with 37 regions available in 200 plus countries. Let us now understand what regions and zones are. In Google Cloud, region is a separate geographical area where you can host your resources. Each region comprises multiple isolated zones. A zone represents an independent site within a single region. Each region typically encompasses a minimum of 3 zones or more. For example, the US West 1 denotes a region on the west coast of the United States that has 3 zones, that is, US West 1A, US West 1B, and US West 1C. In Google Cloud, resources are organized into different levels of accessibility based on their scope. Here is a reframe of resource accessibility. Global resources. Global resources are accessible from any other resource across regions and zones. These resources include pre-configured disk images, disk snapshots, and networks. They can be accessed and utilized by resources regardless of their geographical location within Google Cloud. Regional resources. Regional resources can only be accessed by resources located in the same region. Examples of regional resources include static external IP addresses. These IP addresses can only be assigned to the resources within same region and are not available for the resources which are in different regions. Zonal resources. Zonal resources are accessible only by resources located in the same zone. This means that resources such as VM instance, their types, and disks can only be accessed by other resources within the same zone. These resources are bound to a specific zone and cannot be accessed by resources in different zones. It's important to consider the scope and accessibility of resources when designing your infrastructure in Google Cloud to ensure proper connectivity and communication between the resources. Google Cloud Platform have containers like organizations, folders, and projects that allow you to group and hierarchically organize all Google Cloud entities. This hierarchical organization enables you to easily manage the common aspects of entities like access control and configuration settings. Organizations is an entity in Google Cloud. It is the root node in Google Cloud resource hierarchy and the supernode of projects. The organization resource represents the organization as your company. It contains all the entities that belongs to a company and provide the high-level centralized visibility and control. In our example here, Thinknyx is the organization. Folders are the nodes in Google Cloud resource hierarchy. It contains projects, other folders, or the combination of both. Organizations can use the folders to group multiple projects under the organization node in a Google Cloud hierarchy. Here we have three folders: Department X, Department Y, and Shared Infra. Department Y is having two folders, Team A and Team B, and Team B has two folders named as Product 1 and 2. A project is a fundamental unit in Google Cloud and represents an isolated environment where entities and services are provisioned and managed. There might be multiple projects under organizations and folders. A project is always needed in order to use Google Cloud to form the basis for enabling using all Google Cloud services, managing APIs, enabling billing, adding and removing collaborators, and managing permissions. Here, Product 1 has two projects, Thinknyx and Aman. Resources are the actual entities created within a project, such as virtual machines, storage buckets, databases, or networking components. These resources are provisioned and managed within projects and are associated with specific services offered by Google Cloud. Inside Thinknyx project, we have two resources, VMs and storage. Google Compute Engine is an infrastructure as a service offering within Google Cloud. It provides virtual machines in the cloud that can be easily created, configured, and managed by users. Compute Engine allows businesses to run their applications and workloads on Google's infrastructure, providing scalability, flexibility, and high-performance computing capabilities. Key features of Google Compute Engine include Virtual Machine Instance. Users can create VM instances with customizable configurations, choosing from a wide range of machine types, CPU, memory, and storage options. Auto-scaling. Compute Engine enables automatic scaling of VM instances based on the predefined metrics, ensuring optimal resource utilization and cost efficiency. Persistent disk storage. Compute Engine provides high performance and reliable persistent block storage options for VM instances. Users can choose from SSD or HDD storage types based on their application requirements. Networking. Compute Engine offers flexible networking capabilities, including virtual private cloud networking, load balancing, firewall rules, and virtual private network connections for secure communication. Images and snapshots. Users can now create custom VM images or take snapshots of disk volumes, making it easier to replicate and deploy instances with a specific configuration or to create backups. Integration with other GCP services. Compute Engine seamlessly integrates with other GCP services such as Cloud Storage, Cloud SQL, and BigQuery, enabling users to build comprehensive and scalable cloud solutions. Google Cloud provides a wide range of cloud services and tools for building, deploying, and managing applications and infrastructure in the cloud. Here are some of the ways. Console. The Google Cloud Console is a web-based interface that allows you to manage your Google Cloud resources visually. You can create and manage virtual machines, configure storage, set up networking, create databases, and more. It provides an intuitive way to interact with Google Cloud services. Command Line Interface (CLI). Google Cloud provides a command line tool called the Cloud SDK. The Cloud SDK includes the gcloud command, which allows you to interact with Google Cloud services from the command line. You can use it to create and manage resources, deploy applications, configure settings, and perform various administrative tasks. Google Cloud provides a web-based shell environment called Cloud Shell. It gives you command line access to a virtual machine with the Cloud SDK pre-installed. You can use Cloud Shell to run command line tools, execute scripts, and manage your Google Cloud resources without the need for local installations. APIs and RESTful interfaces. Google Cloud exposes a wide range of APIs that allow you to interact with specific services. These APIs follow the RESTful architectural style and allow you to programmatically perform operations like creating, retrieving, updating, and deleting resources. You can use HTTP request to interact with these APIs directly or use client libraries to simplify the process. Let's now move further for a Google Compute Engine demo using Console. Go to the Google Cloud Console. The address for this is console.cloud.google.com. Hit enter and pass in your credentials. You will land to the Google Cloud Console homepage. In the search bar, search for Compute Engine. Click on that. Now on the Compute Engine page, click on VM instances to ensure that you are on the right page. Now click on Create Instance. Let's give a name to our instance. I will keep it as Thinknyx GCP demo. Under Manage Tags and Labels, you may choose the regions and zones as per your requirement. I will keep it as it is. Under the machine type, you may choose the machine which has the right amount of CPU and memory as per your workload requirement. I will keep it as it is. Let's keep the other configurations as default. Under the boot disk option, we will select the operating system for our VM instance. Click on Change. Now under operating system, we will search for Ubuntu as we are going to use the Ubuntu image and select the right version of the operating system. Click on Select and now go to the firewall option. Under firewall option, we will select the Allow HTTP traffic as we are going to install an Apache web server which uses port number 80. Now click on Create. And as we can see, it is creating our Linux VM instance. The instance is now up and running. To connect to the instance, We will click on this SSH. We can see this is a Linux VM instance with Ubuntu operating system. Now we will install an Apache web server. First we will switch to root user. And now update the packages. apt-get update. This will update the packages of the operating system. It is done. Now let's install the Apache web server. apt-get install Apache 2. Hit enter. Pass on yes. Apache server has been installed. Let's check the status of this server. Service Apache 2 status, and we can see that the Apache web server is active and running. To access this server, let's click on the public IP of this Apache web server. Now we can see the default page of this Apache web server is coming up, and hence our server is running perfectly fine. With this, we have come to an end of this tutorial. We hope you found it useful. If you enjoyed the video, please consider liking and subscribing to our channel. To learn more about our organization, feel free to click on the link provided in the description box. We shall see you in our next video. Thank you for watching and stay tuned for more updates.